right. So, I can now get to what I was hoping to do last weekend, but it took forever to install Unreal 5.1. And earlier, it took some time to compile shaders. And also, I imported the Animation Starter Pack that's compatible up to UE 5.0, but I tried to set it up on the player controller in here and it wasn't working. So, and I don't know enough about setting that stuff up to make it work. So we're going to use, I set the mannequin to Manny because it looked like he had a few more animations. So this is the male rather than the female default third-person controller. So what I want to do is try to make some animation modifiers that, well, right here they've already got some data on here that's saying when left and right feet happen. But I want to see if I can make some curves and determine when feet raise and land. And I've done this kind of thing before, so I'm just going to have to try to recall how exactly I did it. So that's one thing, to be able to animate, or rather populate this timeline with, in this example, we'll just use these markers to say that, okay, we took a step. And also here, like, okay, your foot came right now. So it'd be your left foot came off the ground. And then here, your right foot landed. Right? So that, and then also jumping. We wanted to figure out when is the moment that you actually leave the ground, right? Then we can have foot raise notifies for each of these. And then landing, determining the moment that you land. It may seem kind of like overcomplicating things for this example, but the reason for doing this is if you were in a project where there's way more animations than this, for the default assets, they make it pretty simple. So, imagine that rather than having 1, 2, 3, 4, 5, 6, 7, 8, basically like 8 animations here, we had 800 or 8,000. If there's only 8, you can go in and just manually place the markers or the notifies, and it's not a big deal. But if you have 800, then going in to each one and placing all of them, especially if they're all just like a little bit different, that's a pain in the butt. So that's where something like an animation modifier comes in handy. Okay, so I'll stop jibber jabbering and get started. If you don't know, the way that you can see the animation modifiers is you go to Window and then Animation Data Modifiers, and then this will pop up here. And we don't have our own yet, so we need to make one. So I'm gonna I guess make a folder for myself. I'll just call it OCSFX, since that's kind of the naming convention I'm going with lately for owencoopersfx. And I will make a new folder called Animation Modifiers. And we're going to make a blueprint class based on Animation Modifier. call this BP_AM. Go motion. This will be just for like running and walking. Right, we'll start with that first. Okay. And right now we're not going to add it yet. But as an example, yeah, actually I will add it. So we'll start with the walk, right? So one of the things that I realized before with these, let me add this first, is if you look at a walking or running animation, where the character is going to put, a humanoid character is going to put his or her foot down, is about where the foot is, if you're looking at a delta, so like in comparison to a certain point. So in this case, we're going to use the root because it's just simplest. In comparison to the root, if you look at Quinn, this mannequin, if you look at her left foot, it's easier from the back, look at her left foot from the angle here, then right now it's traveling forward in the same direction that the root is facing. And at a certain point, it is no longer going to be traveling forward, but it's rather going to turn around and start moving the opposite direction of the root's forward vector, or forward axis. So at that moment is most likely when we're going to take a step, right? Similarly for the foot raising, so her right foot in this case, if we look at how her right foot is moving in relation to the root, it's moving backwards. And at the moment that it stops moving backwards and instead starts moving forward, that's about the time that the foot is raising up off the ground, right? And I don't know if I'll have time for this today because, I just don't know how much time I want to spend on this for today. But the other thing to consider is if you wanted to have if you wanted to track the moments that the arm passes the body, then you would be looking at, for example, her hand here, her right hand. When does it pass the root? So rather than looking at a delta, we're going to be just looking at the position. And when the Y position is equal to the root, then we're passing by, right? And then when it goes from being behind the root to back in front of it again, and we pass by it again. So then we can track when the arms are moving past and when the feet are dropping down or raising. And if you don't know already, it's because I'm interested in sound. And so these key moments that we'd be interested in are when the arms pass across the body, so they could make arm Foley sounds like clothing movement of the sleeve. And then, of course, footsteps, right? The all-important footsteps. And the really nice thing about this is if you have a whole bunch of different variations on these walks and runs, then it's really modular to do this. So rather than going in and manually tweaking things to fit the different walking or running animations, you run this modifier and it should handle most of it on its own. Okay, so with that all out of the way, I will try to start making that. So there are two things we need. We need on apply and we need on revert. And we want to cache our animation sequence so we can promote that to a variable in both cases. Oh, also another tip. If you don't know this already, I don't know how I ever got along without doing this before. In this compile button, this little ellipsis, this hamburger, menu, if you go to save on compile on success only, and every time you compile and there's no error encountered, no error or warning, I think actually it'll pass for warnings too. Anyway, then it'll just automatically save it. That way you don't have to save and compile and make them two separate actions. So that gives you less to think about. Okay. So we're going to need to get our frames. Get num frames. And we can set that also. And then what we're going to want to do is run a for loop. From 0 until the last frame. Oh boy. And then inside of this for loop, so in each frame, we're going to be doing this tricky thing that I can never remember exactly how to do. We need to find out where these key bones are in animation space and not just in relation to the skeleton. Because the problem with if you just like try to get a transform from a particular bone is it's going to return the local transform in relation to its parent, which is almost always 0. So if I were to get like, where are the feet? Foot right. Then, yeah, you see its location here is, I'd be interested in looking at its Y location, but it's always 0. So that's no good. So we need to do this. Let's see, get bone pose for time. In this case, we're just going to do it for frame. Just to keep it simple for now. So we need to determine which bones. So let's make some variables. Let's say foot R bone. Foot L bone. And give those some default values. So we're going to be looking at foot L and foot underscore R because that's what they're called on our skeleton. See foot underscore R. And somewhere here there's foot underscore L. Yeah, there. Okay, and we want to check that in comparison to the root. Now this is where it gets weird. Let's start out by caching the current index just to make things a little bit less spaghetti in the blueprint. Index, I'll call it frame index. Yeah, frame index. We'll set that each time we're going to the loop. That way we can more easily get it later. Plug it in here. Okay. Ooh, what's this? Get ref bone pose. Oh my goodness, did they make this? This looks like they realized that this is tricky and difficult to figure out and compressed it into its own node now. But I don't know what this pose struct is that's supposed to be coming in here. And now I open Visual Studio and I'm stuck. Come on. Okay. Because I don't know how to use this, I'm going to get rid of it. But this looks like something that's totally worth exploring at some point. Because that's basically what I want to do. There's something else like get path to root. Find bone path to root. Yes. So we need to go through here. So the bone name needs to be these. So actually let me make this that for now so I know it needs to be filled in. Okay, we want to get the path to the root. Yeah, see, I don't even remember how to do this. Let's see. For each loop with break. We're going to start off with making a transform. And we're going to cache that. As new transform. And then we're going to go through here and find bone path to root. I think in this case, so let's start with left foot. We want to loop through until our bone name equals this? Just take this out. Say root again. So if the name equals root, we'll branch and we will break our for each loop here. Otherwise, we will continue. And then when we complete, then we want to compose a transform here, which is one of the things, again, that I don't really understand. So if I go to compose transform, we're going to want to take our new transform and this get bone pose for frame. And set that to our new transform. Okay. Now let's see what we get from that with a print string, append string, and we're going to say foot L bone position. Need to go get my laundry. Okay, then I will split this out, and we're going to get our location, split that. No, we just want location. I'm going to put that in there. Actually, no, we're going to look at our Y position because Y is the forward vector. Split this. And there's our location Y. Okay. So what happens now when we apply this? Yeah, it's returning the same thing every time. This is why this is tricky. Let's try putting that in. Find bone path to root. And apply. Still the same. Yeah, see, there's some way to make this into like world space. Nope. Maybe we want to break when this equals root. So let me do not equal. It doesn't equal root. Isn't that going to be all of them though? Yeah, that doesn't make a lot of sense. I mean, it's returning the same thing no matter what. This is why this is frustrating. I don't understand this thing. I think maybe rather than doing all this stuff, since we have find bone path to root, we can do get bone poses for frame. And we are going to check our frame index. Oh, there's an issue with this too. These are reversed. I was calling my foot L, foot R, and vice versa. Okay. Preview mesh. Okay, I'm just going to leave it empty. Maybe I need to do this. Every time that we're going through it, we are composing our transform and then when we're done, we have our position. Let's see. Oh, okay, so that is at least giving us something. So what happened there? Yes. Started out at minus 27. And then we, shortly after that, went positive. Went out to about almost 140, then came back. Now, this doesn't make sense, though, because... Yeah, I don't get it. So if I can just get feet working, that would be great. To get a little, I think it's not really working that well, but we can kind of proceed anyway and try this to print out a curve. So add curve key, add float curve key. And we need our animation sequence. And okay, we can only do it by time. We're going to get our location Y as our value, and for time, we need our animation sequence and get time at frame. And we want our frame index. So now we're converting that into time. make this a little simpler. Let's promote this to a variable. We'll call it location Y. That's fine. That way we don't need to have that giant line there. Now the thing is that it doesn't know what curve there is. Is it going to complain about that? No, it's just not going to do anything. So we'll make a quick function for add curve if it doesn't exist. Okay, doesn't exist. It needs a name. We need our animation sequence. Does curve exist? Float curve. If it does exist, then we'll just return out. If it does not exist, then we want to add curve. And we also want our curve name here. Okay. All right, and we can make that pure. Actually, can we? No, because it doesn't return anything. Yeah, that's not going to do anything. Something needs to initiate it, so we can't have it be pure. Unless we return out the name. So let's do... No. It's easier to just make it not pure. Yeah. I just kind of like making the pure functions because they get collapsed down. They look pretty. Okay, so first we will add curve if it doesn't exist. And we will put in our foot elbow as the curve. Okay, it's a bit messy, but maybe we can print out the curve now. Yeah, okay. So you can see this doesn't really make sense because the foot should be going like to some positive Y value and then start becoming negative. And then turn around here and start becoming positive again. So something has not gone right here. Okay, I'm going to take a quick break so I can go put my laundry in the dryer, and then I'll be back. Okay, so I'm back a little earlier than expected. And I found a video where, by, let's see, Ghislaine Giraudeau. Sorry if I'm butchering your name. But really helpful to help me figure this problem out. And let's see what he says here. We need to find bone path to root first, which we have that. And then that's our set. So we need to loop through the bone path. So let's get rid of this. We're going to loop through the bone path. And at each step, we're going to compose a transform. By no, I was right before. We need to get our bone poses for the frame. Let's see our frame index. And then, yeah. It looks like this is what he's doing. We get our bone poses for time or frame, but he has extract root motion checked. I don't know what that does, but maybe that will give us a better result. So let's try it. Oh, I need to revert first. But we're not doing anything on revert, so... does curve... Curve... Does curve exist? Right now we're just looking at the foot L bone. If it does, we're going to get rid of it. Remove curve? Yes, remove curve. Okay, because that's all we're doing for now. So let me revert. That totally didn't work. And this still is not doing what I hoped it would do. Well, can I at least have the minor success of revert working? Yes. Okay, that works. Now, what is wrong with this? again at what he said to do here. Maybe I need to do this first. Doesn't really make sense that I would. That's how he's done it in the video, so let's try it. Promote this to a variable. Then for all of our frames, we'll do this operation. Yep, we don't have anything in the bone names yet, so we take our bone path. Okay, does that make any difference? No. Oh, maybe this is part of the reason why. You only want to do this when it's completed. Let me actually recombine this. Oh. Recombine. So each time that we're going through the loop body, we are composing and caching the new value. Then, when we're done, we're going to get our new transform, split the struct, and we're interested in our location Y. Does that make a difference? No. It looks like it's kind of getting more and more accurate, or doing something more and more the longer this goes, which tells me I'm doing something wrong with my loop here. Let me look again. We have our fine bone path to root. What am I missing here? I might end this stream soon because I'm a little bit burnt out on this, but I will come back to this for sure. It'd be nice if this was more straightforward. Let's see, we have get bone poses for time, and then for each, we're composing our transform. And then our result should be giving us that in world space. But let me close this. And this. And this. It is definitely not doing that though. Wow, I just realized I was muted for so long. Okay. Yeah, what I was saying to nobody apparently was I'm defeated by this. I can't figure out how to correctly get these positions, but at least we were able to get the ability to change which axis you're looking at. And that's editable now here. So we can change which axis is our forward axis. And the reason why would be if you're strafing, moving left and right, we would want to track it differently than when you're moving forward, right? And then also if you were moving backward rather than forward, we would want to track it differently in that case too. Which there'd be I suppose, yeah, there could be a Boolean saying whether or not you're moving backward, but we'll worry about that next time. And I will also get this figured out, how to properly track the transform in world space rather than in relation to the parent bone. And if I have time, I'll do that tomorrow morning. But otherwise, I'll be back here next week figuring this out. Okay, so if you're interested in that, you can tune in then. All right, have a good weekend. I'm out. Take care.